One of the most interesting things that is visible on the sun are sunspots. Sunspots, this is a real pretty picture of some of them. They are dark areas on the sun. They were first observed and recorded by Galileo in 1610. Um, Actually, Kepler observed them with his, okay, I said that wrong. So Kepler saw them first in 1607 and then Galileo in 1610. But 400 years ago or so, these early astronomers were seeing these dark spots on the sun, and they were trying to figure out, what are they caused by and what is the source. This is a collection of some really, really pretty pictures. These are actual reproductions of sketches from Galileo and Kepler showing the sunspots from day to day to day to day to day. That these spots appear and then they move from one day's observing to another across the surface of the sun. Just a reminder, whenever you look at the sun, never look directly at it. If you're looking at a solar eclipse or if you're trying to see sunspots or whatever, the sun is so incredibly bright. Your human self-defense mechanism is going to make you want to close your eyes or look away. But if you are trying to actually get some observations, welding helmets, welding glass works. If you use a telescope with a solar filter, and sometimes something as simple as a pinhole camera. But just a reminder as we start talking about the sun. So what are actually the sunspots? We now know, because we've got more experimental evidence, we now know that the sunspots are actually colder regions. Now, they are about 2,000 degrees colder than their surroundings. Now, they're still incredibly, incredibly hot, but they happen to just be colder than everything around them. Sunspots are visible in that photosphere, which is that layer of the sun we see if we would take a photograph of it. One of the things that's wacky about sunspots is they look very dark against the surface of the sun. But if I could take one of these and put it up into the sky, not surrounded by the glare of the sun, it would look very, very, very bright, because it's still a piece of a star and it's still thousands of degrees Kelvin. Every sunspot has two regions or sections. There is the umbra, which is the dark center, and then there is the penumbra, which is the little bit lighter outer circle. You might remember these words when we were talking about lunar eclipses, and in a lunar eclipse, there is the darkest part of the shadow and the not quite so dark part of the shadow. So we've seen these words before in another context. One individual sunspot can last for days, 5 days, 15 days, 20 days, or it can last for well over a month. They don't last for years like the Great Red Spot on Jupiter, and they don't last for just a few hours like a tornado here on Earth, but they will last for many, many days so that they can be plotted and watched. What do we think causes sunspots? Well, the sun is a very, very magnetic object. It is made out of plasma. Plasma is charged particles, and as these charged particles come up from the center of the sun up towards the surface, they actually have with them, in these convection cells, they actually have a strong magnetic field. What we believe is a sunspot is that when the plasma gets up near the surface, sometimes it is going to cool, and it will just be a cooler region than the areas around it. And these convection currents don't just necessarily stop at the surface of the sun. Some of them are actually going to convect or rotate upward above the surface of the sun. And as this loops of plasma, this is an absolutely stunning picture down here, these loops of plasma come up out of the sun, they have a magnetic field. They loop and they follow lines like the lines around a bar magnet. This is a little magnetic field diagram of a bar magnet, and you can see the magnetic field lines looping up and down from north to south. Each one of these convection currents of plasma coming up from the sun has what appears to be a north magnetic pole and a south magnetic pole, just like a bar magnet. But those north and south magnetic poles happen to be where the loop of plasma comes up, and then the other pole is where the loop of plasma comes down. Weird and crazy observation about these sunspots and their magnetic polarity is the sun has an equator. The equator is just a, kind of a line we pretend we draw through the middle of it. But the sunspots north of the equator are going to have the polarity in one direction, and the sunspots south of the equator are going to have polarity that is flipped. And here's what I mean. North of the equator, here's the south, there is the north. South, north, south, north. Below the equator, it's the opposite. North, south, north, south. So it has a lot to do with the internal magnetic fields of our star. Now, sunspots go through something which is referred to as a solar activity cycle. The solar activity cycle was first recognized in about 1850. And here's the weird and crazy thing. For about 11 years, the sun is going to have magnetic north pointing up and magnetic south pointing down. And then after 11 years, that polarity flips. So you now have the north at the bottom part of the sun and the south at the top part of the sun. And 11 years later, that's going to flip. One full solar activity cycle is about 22 years, from starting with the North Pole on top, flipping, and then flipping back again. This is a beautiful collection of pictures showing the magnetic field lines around the sun. In this situation, magnetic north, magnetic south, real pretty. It looks very much like a bar magnet. During a flip, during a reversal, these are the magnetic field lines you can get around the sun. It looks like chaos, and it is. It's magnetic chaos. This number of sunspots varies over time. There are times where we have, it's called solar maximum, and during a solar maximum, there's going to be lots and lots of sunspots. There are periods of time that are called solar minimum, and during solar minimum, there's going to be very few sunspots. The time between minimum and maximum is about 11 years. And this, of course, corresponds to that solar activity cycle. Now, since the 1700s, the number of sunspots have been tracked. This is one of the few things that we have data, natural data, that lasts over 300 years. And in the last 300 years worth of data, we can graph the number of sunspots over time. And weird and crazy thing is, it goes from 0 to lots to 0 to lots to 0. Sometimes there's more than lots, back to 0, and this goes over and over and over. This periodic shift in sunspot number, you can see, has been incredibly regular, kind of like clockwork, for the last 2,000 years or so, 300 years or so, since we've actually been plotting this. Scientists have produced something which are called butterfly diagrams, and in the lab portion of the course, we're going to look at butterfly diagrams. They're called butterfly diagrams, as you can imagine by looking at this picture, because they kind of look pretty like a butterfly. But what it actually is, it is a plot of number of sunspots. One, like each dot, is a number of sunspots, and the latitudes. If this is the solar equator, and then this is 30 degrees north latitude on the sun, and this is 30 degrees south latitude on the sun. So scientists have kept track, plotted the number of sunspots, and weird and crazy thing, here's what they found. When the solar activity cycle begins, there are lots and lots of sunspots on the high solar latitudes. Over time, those sunspots go lower and lower and lower to lower solar latitudes, and eventually disappear. And when they come back to the next sunspot cycle, 11 years later, when they come back, the polarity is flipped. So if this was north, that is south. This is north and that is south. And each time one of these changes occurs, you get a flip from north to south, from the top to the bottom of the sun. Now, in the solar activity cycles, there are periodically times when things are very, very strong and periods of time when things are very, very weak that we have found through time. One of the ones that's most interesting is something which is called the Maunder minimum. The Maunder minimum occurred 1645 to 1715, and it's a period of time where there were almost no sunspots observed. This was a very low solar activity cycle. During that time, there was a mini ice age that racked the world. And so during that time, it got basically colder on planet Earth. We don't totally understand what's going on, but when there is a minimum in solar activity, the sun is producing less heat, and that less or lower quantities of heat is going to basically make the Earth colder. Now, we have confirmed or correlated the data from the Maunder minimum with tree ring data, where a scientist looks at tree rings and areas where there was a lot of growth, a little growth, lots of growth, little growth, and it totally agrees that the winters were 10 to 15% colder. And that means there's a whole bunch of challenges with crops. There's a whole bunch of challenges with people starving, and it affected governments and religion and a whole bunch of other things. So this has a huge impact on humanity. Currently, we are in a period of very quiet solar activity. It was very, very high back up in the 50s and 60s. It was an area of quite high solar activity. And even 20 years ago, when we hit solar peaks, they were pretty high solar peaks. The last 20 years or so, it has been quiet, and it's getting quieter. So some solar scientists are wondering, are we going through another period of solar low activity, meaning colder, and what effect will that have on planet Earth? Now, some people have even asked or hypothesized, about global warming and the fact that over time the Earth has been getting warm, and scientists believe a lot of that is due to carbon dioxide emissions that humans have created. Maybe, I'm kind of an optimist, if the sun is going through a period of low solar output, maybe this little bit of cooling will give humanity a chance to get our act together. But like I said, I am an optimist. Okay, well, that will finish that little section, and we'll come back next time, and we're going to start talking about flares. See you then.